Hi everyone, I just wanted to do a quick demo of multiplication using the definition of multiplication from Landau. Most people in the problem set that we've been working on, most people were able to get the basic calculations, but I think that some people are missing the sort of general principle that's going on behind these problems. So, you can sort of fumble through a problem and mostly get it, but you may not understand the systematic procedure that is behind it. So that's what I'm going to try and illustrate. We know that 1 times 1, definition of multiplication says that if you multiply 1 by anything, you get 1. So basically that establishes a foundation, right? Once you have that, you can apply that to any number, right? 1 times 2 is certainly the same as 2. 1 times, x, certainly the same as x. So that multiplication by 1 serves as a foundation that everything else is built on, right? So now, let's consider 2 times 2. The only thing that we really know how to do is we know how to use multiplication by 1, right? So what we do is we take predecessors, and we use those predecessors to reinterpret things to be in terms of 1, okay? So you can think of it this way. You've got 2 is the same as 1 successor, and we know that the definition of multiplication says if you have if you have anything successor times a number, you just rewrite it as this number, the predecessor, times this number, plus a copy of this. Okay? And 1 times 2 we know is 2, right? So we've reduced it down to where we have a known multiplication fact. 1 times 2 is guaranteed to be 2, and we know that 2 plus 2 is 4. So that's the general philosophy in multiplication, is that the only thing that we really know how to do is we know how to multiply by 1. So we back things up until we reach a multiplication fact using 1. And this is exactly the same thing as what we did in addition, right? Because in addition, the only thing that we really know how to do is add 1, right? If we have something like, 4 plus 1, we know that's 4 successor. And as long as you can back up your addition to an addition fact of 1, then you're fine, right? So what did we do? If we had something like 3 plus 5, we can think of it this way. We can think of it as 1 successor successor plus 5. By the properties of addition, we can move the successors out. 1 plus 5, successor successor. And now we have an addition fact in terms of 1. 1 plus 5 is then 5 successor. And then applying those successors gives us 8. So I made an oblique comment during class that the general philosophy for multiplication is the same as for addition. And it's just this right here, that if you have everything expressed in terms of 1, if you're adding 1 or if you're multiplying by 1, then you've backed yourself up to a known addition or multiplication fact, and you build up from there. So that's the general philosophy. Take your addition or your multiplication facts and knock it down to where you have something in terms of 1, and then you can build it back up from there.